Hey, this is David from UCR Supplemental Instruction, here to talk to you again about Physics 40b, and this time we're talking about phase constants and simple harmonic motion. So if you don't recall, phase constant is a symbol phi, seen here, and I'm just going to be writing out as phi, that you'll see inside the position, velocity, and acceleration equation, specifically in the arguments for cosine or sine. So you'll see that as omega times t, that being your angular frequency times period of time that you're looking at, plus some phase constant. So the purpose of a phase constant is to adjust essentially the zero time position in a graph. So if we take, for example, the regular cosine graph that we're pretty familiar with, we know that cosine of 0 is going to be 1. And so if t here is 0 and there's no phase constant, then we'll have 1 times a to start with. So if we start at some time equals 0 up here, we have our maximum value a, and we'll just follow the usual waveform and keep going. And so here, we don't really need a phase constant. Everything just follows the cosine function. We don't have to do anything about it. But if we want to look at a graph that maybe it doesn't start at the maximum amplitude, and maybe it doesn't start at 0 either, because we know that sine of 0 is 0, so we could easily just switch the cosine to sine if that were the case. Let's say, instead of this, it starts somewhere in the middle, about 1/2 of a. And from here, well, there are two different graphs we could draw that could start at this point. The first one is starting at the top, or starting here and going up rather, before it comes back down. And then we have another version of this that we could do, which would just go straight down. And so if I just told you where this started, you probably wouldn't be able to say which one of these the line is going to make. So how can we find that out? And what does the phase constant have to do with that? So if we again go back to just using cosine, if I claim this to be 1/2 a, the starting point, we would know that whatever the answer to this equation is, regardless of phi, has to be 1/2 of positive a. So which of the phase constants will do that for us? So, well, we know that a cosine of pi over 3 is, or sorry, pi over 3 is going to be 1/2. So that would make sense, right? If the whatever omega t plus phi is 1/2. And again, at the beginning, t is 0, so it would just be pi over 3. But of course, we go to our unit circle here. We know that it's not quite that simple, so pi over 3, because the cosine of negative pi over 3, or you could do 2 pi minus pi over 3, is also 1/2. So you have two possible phase constants for the same thing. Well, as you might have guessed, they're not identical. One of these phase constants relates to one of these lines, and one relates to the other. So just write out what these are so we can refer to them. So we have the constant for pi over 3, and the constant for negative pi over 3. All right, well, let's experiment to see which one's which. All right, so again, just plugging in here, you'll get two different answers. So an easier way to do this is then to go to the derivative. It's because what we can see here is that the derivative of these are going to be opposite, and one's going down, one's going up, and the derivative just being the slope. And so it's also the velocity equation, which we should already know. So E of t is equal to, if we're using cosine to start out with, negative a times omega. Again, that's just the chain rule, sine of omega t plus phi. So this is our new equation. This can tell us, well, the velocity is a derivative of the position, so we don't just have to look at this by inspection. All right, and so the phase constant is going to be the same throughout. So let's plug in, let's assume that pi over 3 is going to be this red line. So let's go ahead and plug in pi over 3. Now, we don't have to worry about all of these values, even though the equation gets a little more complicated. So if we plug in pi over 3, and again, t is 0 at this point, the sine of pi over 3, as we can see, is just the vertical distance between the origin and the point on the unit circle. So it's going to be a positive value. And actually, at this point, it doesn't really matter what that value is. We just know we have a positive number for sine of omega t plus phi. If you multiply that by the negative number, of a times omega, we'll just have a negative number. So what that means is that the velocity at position 0 is actually going to be negative. So which of these two curves represents that? Well, as you might have guessed, it's the blue one, not the red one, as we might have assumed. And that's because it's already going down right at this point. So we know that the slope is negative, then the velocity is the slope and is also negative. All right, so let's double check that then with negative pi over 3. So again, we don't really actually have to do any real math here. We can just see that the vertical distance from the unit circle to this point on the unit circle is negative. And again, it doesn't actually matter what it is. If we have a negative value for the sine of omega t plus phi, multiply that by another negative value of a times omega, then the velocity is positive. And so that's the opposite answer. And we can see that the red line will correspond to that. All right, so it's probably maybe a little counterintuitive that the line that starts positive has a negative phase constant and the line that starts negative has a positive phase constant. But I also like to think of it as just the graph translations that you've probably done in middle school or like algebra 2 or stuff like that, where if you have a parabola and you want to move it to the left toward the negative side, you add something to the argument of x. So it's sort of similar. There are several different ways you could remember it, but taking the derivative and of finding whether it's positive or negative is a pretty fast way, even though it doesn't look like it, because we're dealing with a whole new equation, figuring out which direction you're going to be heading. And again, you don't have to worry about the value of a or omega. You don't really have to worry about the value of sine, just whether or not it turns out to be positive or negative. And again, since we're starting at position t equals 0, which is usually going to be the position of the most concern, it becomes even simpler because when we just go to the unit circle, is it positive or negative? All right, so that's all. Hope you learned something, and I'll see you next time.